have a look at solving two-step equations now. Very similar to one-step equations. What we're going to do though is we're going to apply BIDMAS but in reverse. That's how we're going to know which of these numbers to move over to the right-hand side. So if you remember from one-step equations, we like to keep the pronumeral on the left-hand side and we want all the numbers to be on the right-hand side. And that's really the aim. And that will result in our solution, which is in fact the simplest equation that we can come up with. So 2x plus 1 equals 9. 2x means 2 multiplied by x plus 1 equals 9. So according to BIDMAS, addition is done after multiplication, so that's the first thing we're going to move over. Okay, so 2x is equal to 9 minus 1. Okay, so 2x is equal to 8. Now, 2 and the x, when you have a number and a pronumeral next to each other, it means multiplication. We're going to move the 2 over, and the multiplication will then turn into a division. Okay, so x is equal to 8 divided by 2. Therefore, x is equal to 4. Now, we can test that in our original equation. So 2 times 4, okay, is 8. 8 plus 1 is equal to 9. And we're happy with that. Let's have a look at the next one. A over 3 minus 2 equals negative 5. Now, when we have a fraction written like this, really it's division. So I'm going to write it again, but using the division symbol. So A over 3, okay, minus 2 is equal to negative 5. Again, according to BIDMAS, okay, the negative or the minus is done after division, so we're going to reverse that and do it sort of backwards. Okay, that's really what we're really doing. We're solving an equation where it's like unwrapping a gift. We're taking off the outer layers and we're getting to the pronumeral and isolating the pronumeral. Okay, which is really the gift, isn't it? Okay, so we're going to move the negative 2 or the minus 2 over the other side. It's going to become positive 2. So A divided by 3 is equal to negative 5 plus 2. Okay. A divided by 3 is equal to, now negative 5 plus 2 is negative 3. Finally, we're going to multiply both sides by 3. So A is equal to negative 3 multiplied by 3, because the opposite of division is multiplication. When we move that divided by 3 over, so that's going to move over the other side, it's going to become multiplication. So therefore, A is equal to negative 9. Okay, when you have a negative multiplied by a positive, we get a negative. Okay, let's see if this actually works. So if you go back to the original equation, negative 9 divided by 3 is negative 3. Negative 3 minus 2 is minus 5 or negative 5. So we're all good there. All right, so look at part C. 4x over 3 equals 20. Now, with fractions that have numerators that have more than sort of one object or one term or two things sort of multiplied or added together or whatever, actually there's implied brackets around the numerator. Okay? So I like to put the brackets in because it reminds us of what the difference is between fractions and division. Okay? While fractions and division are very similar to each other and are practically identical, the one difference with fractions though is that, compared to division, is that there are actually brackets which we don't show normally, but they're there. So 4x divided by 3 equals 20. Okay, so that's 4x. I'm going to put that in brackets there. Divided by 3 equals 20. Okay, now according to BIDMAS, brackets is always done first and then everything else. Okay, so we have the division by 3, which is outside the bracket. So let's move that over first. So we have 4x is equal to 20 times 3. Okay, now 4x is equal to 60. Okay. Now the brackets actually now don't do anything. They don't add any extra meaning in this line here. Okay. So what I'm going to do is I'm going to just write it without the brackets. Okay. We're going to divide everything by 4 now. So 4 times x equals 60. Okay. So x is equal to, hopefully I can fit that in, 60 divided by 4. Okay. And therefore x is equal to 15. Does that work? Let's see. X equals 15. Let's substitute that into the original equation. 4 times 15 is 60. 60 divided by 3 is 20. So I think we're happy with that. Okay, so I'm going to sort of squash it up a little bit there. Let's have a look at part D. Okay, so A plus 2 over 3 equals 4. Now, like what I did with part C, okay, it looks like as if we need to move the plus over first, because according to BIDMAS, the plus is done, or the addition is done after the division or after the fraction. But remember, with fractions, there are implied brackets around the numerator. Okay, so we're going to put when I say implied, it's like invisible. Okay, sort of invisible brackets that are meant to be there. So I'm going to write it out again, this time with the brackets, but using the division symbol. So a plus 2 in brackets, okay, divided by 3 is equal to 4. Now, according to BIDMAS, we do the brackets first, then we do everything else. Okay, we're going to do that in reverse now. So the reverse of BIDMAS is, if the brackets we do first, when we're solving an equation, we do them last. So let's get rid of let's move the division by 3 over the other side. It becomes multiplication by 3. And what I'm going to do as well is that I'm going to also remove the brackets in one step. That's equal to 4 times 3. Because now we don't need the brackets anymore. The brackets have served their purpose. Okay, so a plus 2 is equal to 12. Okay. Now it's just a one-step equation now. We're going to subtract, we're going to take the plus 2, it's going to become a subtraction. Okay, so a is equal to 12 minus 2. Okay, therefore a is equal to 10. Does that work? Let's go back to the original equation. 10 plus 2 is 12. 12 divided by 3 is 4. And that most certainly does work. Okay, it's very important that you check your answers, okay, as you do these. Okay. If this was in an exam or a test or a quiz or anything like that, especially when you don't have the answers provided, it's actually quite easy to check your solution. Okay, so substitute it back into the equation and just check that the left-hand side, the value of the left-hand side should equal the value on the right-hand side. Okay, let's have a look at part E. Now, part E is kind of a strange one because it's 5 minus x instead of x minus 5. You usually have a pronumeral subtracting a number. What if it's the other way around? So our first step, what we're going to do is we're going to reverse or switch the 5 and the x around first. So instead of 5 minus x, I'm going to write it as x minus 5. But when we do that, we have to also switch the sign of the number on the right-hand side. So if that's negative 2, it's going to become plus 2, positive 2. Okay. Now it's become like a regular one-step equation. X minus 5, the minus 5 moves over, becomes plus 5. So x is equal to 2 plus 5. Therefore, x is equal to 7. Does that work? Let's substitute back into the original equation. 5 minus 7. Yep, so if we put a 7 there, 5 minus 7 is equal to negative 2, and that works. Now, the reason why I put this in under two-step equations is because of this very important step, that if you wanted to make the pronumeral positive, okay, you want to switch those two around, that's okay, you can do that, provided you change the sign of the number on the right-hand side. Okay. Yes, things can get more complicated than that, but when it's a simple equation like this, okay, where you might have just a number and minus a pronumeral equals just a single number on its own, it's fairly straightforward. Okay, just switching those around. Last one. So we got 1 over t is equal to 4 over 5. Okay, so now we have a pronumeral that's in the denominator. Okay. Now this one's definitely one that you don't see as often, at least at this point. In your mathematics journey, but they will come up at some point. But it's good to know how to do these, and it's actually not very difficult at all. What I'm going to do is I'm going to write it as a division. Okay, so 1 divided by t is equal to 4 divided by 5. Now, one of the great things about equations that involve fractions on both sides is you can in fact switch everything around, because the pronumeral, when it's in the denominator, it becomes a little bit harder to solve. So rather than 1 divided by t, I'm going to do it as t divided by 1. But when you switch those two around, okay, the 1 and the t around, you need to switch the 4 and the 5 around. Okay. We can also do this without having to write it in division form, but I just wanted to show you in this form what happens. Okay. So when you have two fractions like that, you could also switch them around. So I'm just going to show you an alternative. Okay, so t over 1 is equal to 5 over 4, okay, and t over 1 is just t, okay, therefore t is equal to 5 over 4, or 1 1/4, okay. Now you can substitute that into the original equation, see if it works, use your calculator. 1 over 5 on 4, okay, will equal 4 on 5.